Okay, Svein, if you want to intervene now, the floor is yours. Thank you, chapter.
Yep. Thank you, Chandra. So giving you a little bit break here. Yeah, I'm going to go a little bit through the boundary profile, which is more rather the boundary profile is more instance data describing the boundary. Next slide. So we in the 2.4 we have had quite a lot of issues dealing with the boundary. It works fairly well with boundaries on the transmission lines or generally boundary on the line. However, when you have boundary inside a substation, which is very likely on distribution, you get challenge. We also have a huge challenge in regards to finding the boundary points for HVDC. So when you're going to have different masses with HVDC in regards to AC, you need to have this kind of boundary inside substations. So what we generally have done is we have in CGMES 3, we have deprecated the whole equipment boundary profile, meaning that it's still valid per se, and it will still work for the boundary on the transmission on the line. But we are opening that any items in general in the EQ profile can be part of a boundary agreement. So the vocabulary or the item is now covered by the equipment, and it will also be covered by when extension is covered, that it could also be part of any boundary. We also done adding a boundary point class as an EU extension to accommodate information on the connectivity node, so that the connectivity node itself is defined is the same regardless of the profile is included, but the boundary connectivity node has a boundary point pointing to it to indicate that this connectivity node is under a boundary agreement. We have in general deleted the whole topology boundary, and the reason for that is that we consider now topology node purely output. And this is to deal with bus branch and node breaker, which Stefan is going to be elaborated more under later on. But in general, we are now kind of forcing the bus branch tools to add a connectivity node. In principle, that will be very much the same as their topology node, so that you can then expand on any switches. And the reason for that is that even if we are moving in the work that everything is node breaker, we have the challenge that you have a hybrid. So the SIM in 2.4 works well with you have a node breaker model, a bus branch. But if you're merging them, so you have some mouses with node breaker and some with bus branch, in general, that means that you are bound to the least detail model. So everything becomes a bus branch. However, that becomes a lot of issues because the reason you're putting node breaker in there is to have the flexibility of node breaker and that you can do topology processing. Now with this, we are making the adjustment so that you can have node breaker and bus branch being merged to the same, but is underlying kind of the node breaker structure by having connectivity nodes. So the topology now is done with the topology processing that's dealing with the node breaker. And we have the boundary parts as being persistent and the connectivity node also being persistent. Then the topology node will then be generated as part of the IGM. So you have the topology, but this may not be the same topology node as being created in the CGM. So previously there's boundaries, so the topology engine has to make persistent the identifier of the topology to make the alignment. That is no longer needed. And in the so in the CGM, the topology, you have one topology instance that covers all of them, where you align the topology based on all the equipment and the SSH. Yeah, and then the yeah, wait a little bit. So so the fact that now that all the equipment in the topology and EQ can be boundary. So in principle, you can then say a whole substation is in my boundary model. And this is particularly relevant as we're moving into to other area where we're having like system protection schemes that is shared among different masses, and then you cannot have duplication of this. So we are expanding it. Like currently is in principle the line container is there, but in moving forward you need to have multiple items. So in the CGMES 3, we have left kind of this as being a bit open. So this is the idea here. But we have published or in the process of publish. We have shared it with the we're in the way of publishing our constraints that from the ENTSO-E point of view for constraining the CGMS. And this will be then integrated in upcoming versions of the CGMS. But in general, the whole area of boundary management is covered by the CGMES 3, but it doesn't give you the necessary constraint. Next slide. So as you see here, we have in the boundary, and then this is just barely showing the connectivity node, and that the topology node is now inside the masses. And when you have the topology, you create the linkage for the connectivity node to the topology that each of the masks produce. So that's different from previously that you have the topology node inside the boundary. So that's no longer inside. And below, you can then see that when you are merging it, you're getting an SV and a TP for the merge process that symbolize the solution for the merge model. And again, here you're just showing two masses, but in principle, it could be the pan-European model. Next slide. Then the boundary package has three options so the tooling needs to kind of support. We have the option B per region, and the region could also be pan-European, which is how it is currently. We only have one boundary file that covers all the TSO. As we're moving to support DSO, that becomes an impossible task. Our general recommendation for the tooling and what you should be prepared for is to do option A, that you have versioning. So in a way, you need to version each of the boundary points per border. So between two system operator like A and B, you have that version, and then you can deal with all of the one that you are managing. This could be a little bit constraints for your internal system if you are only having tools that doesn't need to calculate any of your neighboring model. So option C is meant to support that. So you can have one boundary that you are creating for that TSO, a version control on that, and so that you can align it. However, the general idea is that you can then validate always one mask by itself. That should be possible, but also that you can validate it with that boundary. And so what for us to be able to do that kind of validation, we need to make the possibility that the boundary data can be duplicated in the data sets. show more on that on the next slide. We'll talk about that. But yeah, back to the first one. So it shows here TSO, but these can also be DSO, so system operator. It can also be significant grid users. So all depending on how you are splitting up the model. So you should not make kind of any restriction on the idea of how you put the masses. In addition to being kind of TSO, it can also be different systems. So the way you partition the model can be quite a lot of flexibility, but the general idea is that you have a boundary and also that you use equivalent injection on both sides so that you can in principle do power flow inside a mass, because the real validation is, or getting the ultimate level of validation is that you can actually run power flow. So, and also the region that could deal with the TSO, and also with HVDC and so on. Next slide. So here you can see the way that you have different IGMs or masses, and this is showing how this boundary that you need to have some items that are equal are known. So if you have a boundary on a tie line, you need to have the line, the identifier of the line consistent, so that you can have those green arrows pointing to the line container, both from the AC line segment and from the equivalent injection. So in the CGMES 3, we also say the equivalent injection is the preferred way of representing the other side. So the most simplified equivalent of the other side. That doesn't mean that you should be able to have equivalence on the IGM itself, but you need to have the equivalent injection on both sides so that you can align the power flow. And bear in mind that this could also be used from transmission to distribution, so that the IGM 1 could be transmission and IGM 2 can be distribution. And then you have your power solution pointing to the different terminals, and they're all aligned with the boundary. And in the boundary, we have now the EU boundary point, which is something we could have shown in the diagram here, which is pointed to the connectivity nodes, and so that the connectivity nodes are the same regardless if it's part of a boundary or part of the IGM. What makes it a boundary node is the fact that it has a boundary point pointing to it. So, and one of the key things that we want to do is to make sure that we have the IGM and we can validate on themselves. Because if we are doing an assembly, we fail to do the assembly, we need to figure out which of the IGM is wrong. And the idea that you can validate the IGM on its own is important. And that leads to the need to have some duplication. And that's particularly with the TSO-DSO exchange. Next slide. So here you can see a bit of the duplication, and this is showing the duplication primarily on the containment, so that you have the substation 1 being in all three masses here. So it's in mass 1 and it's also in the boundary between mass 1 and mass 3. And it's also in the mass 3. But bear in mind that anything can then be as part of this boundary. So you need to know that you can either have it that is not reflected, or you can have have it so that you end up actually with 3 instances of like substation 1. And the key then is the value that is in the boundary. Those are the one that you need to validate the 2 masses against. So if there's any differences in those, the tool should report that to be incorrect against the boundary. And then you can also include the you can end up with also a MOS 3, which has a separate substation, and you align these things being matched up, and you go down to where you actually have like bus bar section or whatever the items is considered the boundary being included here. And again, as I said, this becomes more relevant when we are expanding it to deal with system protection schemes, which will need to be duplicated as a minimum between the different actors. I think that was it. So any question on this?
I see nothing in the chat, but yeah, we have Lino.
So that probably means I did not give it a good explanation.
No, I think you explained it quite well, Svein. I have a question, because you say basically the boundary can be duplicated, but then in order for this to work, the IDs have to match in all 3 masses. So this still means some sort of agreement between the entities. But this agreement is then done how? Do you predict how that is done, or this is just implicit?
There might be a need for application to do this type of boundary agreement, which we have at the TSO level. However, I am seeing that this agreement, when we are building new lines, will be becoming part of the long-term project. So you will actually have this when you're going shorter distance. So when you're aligning it. However, it could be a need for application to be able to send it, but I'm just basically sending you send, or you find a way to have an agreement, because that you just do it once, and after that you have it.
Okay, thanks.
Thank you, Lino, for the question. Anybody else?